Alright, YouTube. Hello, thank you for watching. I just want to say right off the bat, I had a couple really nice comments to me, and man, I completely did not expect that. Actually, to be quite honest with you, blew me right straight out of the water, because I didn't think that anybody had any damn interest in watching anything that I do. Um, just to put it to you that way, I really didn't. So, like I said, I'm just a small fish, man. I'm not a big old window dresser. But hey, I do appreciate those comments. Holy cow. So, you just never know what I'm going to say on YouTube. Maybe that's why I started to get more views lately. I don't know. Maybe my true personality's coming out. So, anyway, here I am. We'll kind of get back to that. So, here I am with a little DX250. Somebody brought me a long time ago. Said go ahead and keep it, see what you can do with it. Story is, when I first got this thing, pulled my damn hair out with it. Couldn't get more than 110 watts out of this thing with my drive that I have, which is that little TRC 465 there. That's what I'm referencing against. So played with this thing and played with this thing over months and months and months. Every once in a while I'd pick it up, do something else to it that wasn't the answer, put it back on the shelf. So today I think I finally got it. I might just stick the damn cover on it and call it quits, because I'm completely out of things to do to this amp. So the last thing I did here, right before I turned this camera on, was I changed out the resistor for this big old 80s Mako meter here. It was slamming pretty hard. Hello, 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 hello. So it's not quite to the pin mark, which is exactly where I want it. I'm kind of dwindling my battery voltage down right now, because I think there might be something I want to show you here that might be able to teach you something. So I'm setting at about 12.8 now. Hello, 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 hello. It does actually come down to around 12.4. So just kind of let it wind down here for a little bit. So, oh shit, man, where to begin with this thing? This thing is crazy here. Holy shit. I've never actually had one of these things grip like this one does. Good grief. No doubt you got a connection in that plug. So before I forget to say this, I think I got one more video. Well, I don't think, I know. I have one more video after this. It's actually on another Texas Star 250. And then, man, I don't know what's going to happen here. I mean, I got some good educated guesses, but I kind of have my doubts if there's going to be any more electronics videos going on YouTube. If there is, it's very, very likely, I would say, there is going to be no more CB radio videos going on YouTube. And yeah, that's kind of what I'm saying. Shit, man, where to begin with this, really? I did so much to this. So here I am. You just never know what I'm going to say. So here I am talking to my buddy on the radio a couple weeks ago. Really good guy. It's probably one of the few reasons I was picking up the mic for. If you can kind of read between the lines here. So I'm talking to him on the radio, and next thing I know, I hear this voice come on, and the guy says my numbers, and this guy calls me a faggot. So I'm sitting here, I about fell the hell out of my chair, and I'm thinking, there's no way I just heard this guy say this to me. So I kind of like stumbled around here in my head for a couple minutes, and of course I did the thing that I would do. I went and grabbed my damn keys. I had no idea if this guy was local or not, but it was just kind of like an instant reaction for me. So I grab my keys, I go out and get in the car. I'm going to go find this guy. Luckily, for his benefit, he did not turn out to be local. But I just reacted to it. And You know, I guess what I want to say here is, I'm actually kind of heading in a direction with this. You don't do that where I come from. And especially you do not do that to somebody that's got a screaming history of post-traumatic stress disorder that has been through some wars. You just don't do that, because there's a very good chance some bad things are going to happen on your property. That's that's all I'm going to say. So what I'm getting at is this. I put a lot of work into this amp. I don't have a need for it. And that kind of sucks. I see no need to have a radio turned on. Because the next time, it is possible, very unlikely, but maybe the next time it won't be somebody in Texas. You see my point? I don't need that. I've done probably, 200 videos. Hardly any of them have ever made it onto YouTube. Just FYI. I kind of have a feeling if I wouldn't edit out a lot of the things that I say, I probably would have probably would have some viewers. Man, getting to my point, I'm sorry. I had about 110 coming out of this guy when I first got it. Went through, did a shit pile of work to it. First of all, just to start with the basic stuff, the meter was no good. Of course, you can't buy them, so I put a Mako in it. These Mako meters are 1 milliamp full scale, so you need a boatload of current to spin the meter movement on these guys. So I had to change out this resistor down there, which I just changed a couple minutes ago to set it where it needed to be. I had to change the value of that cap out on the rectifier there. And then I changed the whole front end of this amp over. And boy, I couldn't even, there was so much work involved in this shit, I couldn't even really tell you, unfortunately, exactly what was done. But this 33 here was originally, I know for a fact, setting over here. Where this 33 sets, there would have been a 68 down in there originally. This 75 never would have been in there. It was put in, there would have been a 120 that would have been occupying half the space here. That would have been setting down on the board. That was taken out. There was a 10 in here that was jumpered out. In addition to the resistor changes that were made up here and how things were kind of reconfigured, there was one other thing too. There was a path that went from this end pin right here, which was the RFN. It came down and it wigwagged over here to, I think it was the third pin in, right here where the orange wire is. It had to be cut and shifted up, just kind of jumped up. It was only like basically less than 1/8 of an inch space to jump it back up, and jump it back up to this pin on the switch. And then just added this wire down onto the transformer. Basically what that did is it gave this AM, what used to be the AM button here, dial-a-watt function. The obvious difference that there's no stinking dial-a-watt. There's no potentiometer in there. So that's what this 33 ohm resistor carries out. It just acts as basically a fixed dial-a-watt, if that makes any damn sense. So it's just another way of adding one different level of power to the amp, since there's really no way that you can put a pod in this. I mean, actually, technically, you could put a pod in it, but I didn't want to go through the trouble to do that. I just converted the front end of it into the transformer, is basically what I did. These droppers were put on because I changed out the bulbs in it and put something in it that makes some damn sense. I put 8.2 volt bulbs in it, put some 39 ohm droppers on it. The interesting thing about that is my bulbs do not actually make contact through the socket, but they set inside the socket. That was a whole fiasco to do that. So replacing the bulbs, if these bulbs were ever to go bad, would be significantly more trouble than pulling out the cheesy 14 volt bulbs that were in it. But the good thing is these are 50,000 hour bulbs. These things just don't go bad. So you might be able to see what I did is I put Teflon tubing on the leads there and then pulled the leads back through the little slots there and then soldered them back. That worked out pretty well. It's actually got really good illumination on the buttons now. It doesn't look like a doesn't look like a pile of shit, really. I dropped some turns off this transformer. I got one turn on it. Pulled their cheesy little 1-inch transformer out, put 1.25 inches on it. We changed the feedback resistors to effectively 37.5 ohms, 275s in parallel. Put an Arco 429 on the input to tune it. I think it's padded with 100. Got an Arco, I think it's a 403 back there, that's being padded by a 68 mica underneath it to tune the output. I think the 403 Arco is probably about, hell, I don't know, probably somewhere around 8 to 10 puff to probably 40 plus with maximum compression against the 68, so the compiled effect of the two in parallel. These are still 330s. I put a pair of new old stock Toshibas in that are Toshibas 2879s. I just stuck a new relay in the other day. I have a video on, that'll be my last video on sticking a relay in one of these guys because I had another one of these amps, so I videoed putting a relay in it. If you can even hang through it, because it's like 45 minutes and took like 7 weeks just to edit it. But that's a Zettler. This is actually the amp that I put an RM Italy preamp in, which is kludged over here. Yeah, oh, and the obvious thing, I put a bias regulator in it. The reason I did that is because this thing didn't have any bias current, and I just had enough of button with this resistor here. I mean, it just does not make good sense to try to adjust your bias off a critical value like this. I mean, 1.6, 1.7, 1.8 ohm. You just can't dial it in by changing that resistor. And you can't even get a 1.7 ohm resistor. So I did the thing that makes sense. Instead of changing the damn resistance to adjust the idle current, you change the voltage. I mean, that's how you do it. Then you can dial it to anything you want. Made that little board there for it. So that took a couple hours to make this guy here. Put him on a little piece of perf board, so there's the voltage adjustment. What did I use? Probably an on semi LM317. So what I did was VCC comes over from the relay here to feed the top side of that resistor. That's the original 25 ohm Texas Star resistor I left in there. I didn't take that out and change that around because I like to try to leave everything original in an amp that I can and just add to it, because I'm kind of funny about stuff like that. So I just padded another resistor across the top of it to make it what it needed to be. And it ended up to be like 13.2 ohms, I believe, if my memory's right. So what I did was I just cut this leg of that resistor, lifted it up off the board to isolate it out of the circuit, and then just tied my voltage regulator in from the point where it was connected. Right here is where the lead was cut from. Goes into the voltage regulator and comes back out and goes back to that side of the resistor. So it's actually paralleled with a 27 ohm 5 watt there. Wasn't ideal to stack another 5 watt up there, and that's a pretty damn expensive resistor, but that's all I had. And that works very, very well. That's why I put the usual insulator underneath the board on it. So I just want to point out something here while I'm kind of thinking of it. You can fit an 1.25 inch transformer into these if you really want to. It's just going to be a little difficult to do it, but you can do it. If you have the board out, it's going to be a little bit easier to do it. The only reason I say that is because of making your B plus connection back here on the back side of the transformer is going to be pretty impossible to do it without the board being out. Now I did this one with the board in. And it will take you from the front of the transformer. You will be smack right straight up against the damn collector leads here on the transistors. That's how far it's going to be pushed forward. And on the back, you're going to be right at the very damn edge of the trace on the bottom for VCC. So it's going to fully occupy the space, to say the least. That's why I have another piece of wire bust in here, because you can't get down in there to solder it. There's probably about, well, I don't know, less than 1/8 of an inch, that's for sure. Well, I'd say more than a 1/16, less than 1/8 of trace to solder the transformer to. In order to change the meter on this, for obvious reasons that you know you can't buy shit anymore, I had to put that Mako meter in. So it's got the big 80s look to it. So I had to change the value of this cap out because this meter draws more current and sucks more off of it. And I had to change out the series resistor too, because this Mako meter is 1 milliamp full scale. The original Texas Star meter, I think, was something around 500 microamps, but I don't think it was 250. Kind of leaning more towards 500 microamps, or something oddball, slightly less than 500 microamps was full scale on the original meter. So there is a 1.6 in there right now on the bias resistor. If you were running 12, 13 volts on this thing, there was absolutely no idle current at all through the collector emitter junctions on these transistors. I'm not much for presentation, I'm really not. What's on that regulator board? And there's going to be a little bit of educated guessing here because of this. They are precision resistors, and they are on blue resistors. So there's no way in hell to tell what they are from the band colors. The blue that underlays the resistor screws up your ability to determine what the colors are on top of them. That's a bad thing about these precision resistors. It really is. You just can't tell what the hell the colors are. So I'm going to have to extrapolate a little bit from memory. And I do so much of this, man, my memory could be off. This really could have been anything. It could have been a 232. It could have been as high as a 246. Because I know those are all standard values that I use. That's an LM317. If you never messed with LM317s before, watch what you buy. They're not all equal. As a matter of fact, every damn one of them are different. Some of them will do less than 500 milliamps. Some of them will do more. It depends on a million variables. So you just never know what kind of current you're going to get out of them. It depends on your input voltage, your output voltage, and a boatload of other technical things. Clearly as I can put it. So that's that cap, both electrolytics. There's a 2.2 mic tantalum there. Actually, I know there's at least 3 chip caps on the back. There might be 4. Right there, right there, right there. There's a 500 ohm that I needed to knock down, if my memory's right, to like 390 some ohms or something like that. I think it came out to be. So that's why the 1.8 is padded across that 500 ohm pot to give me a pretty precise voltage range of what I needed there. So that guy there was sat down on a piece of ceramic. Did that for a reason. So all I did was just break this resistor connection there. That's the easiest way to do it. This is the only place it could mount right there. And just insert the regulator into it. So just cut that lead off the resistor there. From where it was connected right there. Run that into the voltage regulator through that RF choke. Comes in down there. Back out on the blue wire, which reconnects the resistor back in. That's all there is to it. The existing 25 is still in it. There's 27 paralleled across the top there to knock that down to, I think it was about 13.2 ohms. Alrighty. So the big problem was couldn't get more than 110 out of it, no matter what. I'm actually trying to drain the battery down a little bit because there's something I want you to see. Try to dim the light down a little bit that way. Hello. Alright, that's what I wanted you to see. The amp's pulling 25 amps right now, and 12 volts of VCC to it. So if I stick this thing on storage mode, you kind of see what's happening up here. We're kind of flattening up. If I take this out of storage, hello, 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 hello. See what's kind of happening there? You're kind of getting a brick wall. Hello, check, check. Hello, 1, 2, 3, 4, 5. It's going up, it's hitting the point, and it's saying that's it, that's all there is, we're flattening. So if I jack my mic gain down, turn it off of nuclear here on this K40 mic. Hello, check, check. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You see, we don't have that. Now if I go back up on the nuclear setting, hello, check, check. 1, 2, 3, 4, 5. Now we got more block wall happening up there. I'll tell you why that's happening. Now this CN901, it's not a great watt meter by any means. And I don't want to get into why that is right now. Hello, hello, hello. So 200 on the button. We know the amp is getting probably slightly less than 12 volts. Hello. So that's why I say it's probably actually getting slightly less than 12 volts. Because this is actually monitoring the voltage right down on the battery terminals, which is about 10 foot away. So the reason we're getting that flattening is because these transistors are fully saturated. And what I mean by fully saturated is they are getting more than enough drive to completely turn them on. Turn them on to the point at which they can no longer produce a change in voltage. So looking at these transistors, and I'm not going to try to school you in transistors for sure, but these transistors are just like a water, like a water faucet. You give a little crank on the base of them with the handle, and then you get something flowing between the emitter collector. So the more you give them on the base, the more flow you get on the emitter collector. Just like turning on a water spigot. Well, these guys are turned on to the point at which they can't turn on anymore. So if you were to put a scope across the collector here to ground, and unfortunately I don't have my real good scope out right now to show you, but if you took a real good oscilloscope and put it on differential mode and connected it across the collector to ground, you would see that the voltage between that point is pretty darn small. It's definitely going to be under 2 volts. And the reason for that is these are fully saturated. So when a transistor is turned on or saturated, I mean normally, and it varies amongst a million variables, but you get a saturation voltage. Let's just say 0.6 of a volt. So when this transistor is fully turned on, you get 0.6 of a volt sitting on its collector. Being it can't go any lower than 0.6 of a volt towards ground because transistors aren't perfect switches. So what happens is there's no more change in the output. There's no more change in voltage. There's no more increase in collector emitter current. There's no more change in anything. It's just maxed out, to put it to you that way. You run into a block wall, and that's why you see that level out and just kind of flatten. Just kind of like you're pushing something up against a wall. You go so far with it and it says, nope, that's it. There's a damn wall there. I can't go any wider. So that's what's happening. So saturation really isn't a good thing, but saturation tells you that your transistors, for whatever reason, are putting out every last single drop of power that they can. And just kind of backing up, I will tell you this. Running transistors completely in a saturated state is, like I said, it's not a good thing to do. So you're probably thinking, well, then why are you allowing this to happen? Well, like I said, this amp was nowhere near its potential. It wasn't even remotely damn close. So the fact that these transistors are saturating on me now, I got power coming out of it, is actually a good thing in retrospect to what it was beforehand, if that makes any sense. So ideally, I would not run a transistor saturated, and in order to get it out of saturation, all you have to do is reduce the input power. Because you can see what happened there when I backed my mic gain off. You didn't see, I don't want to even use the word flat top. You didn't see it hitting the block wall up on top of the scope because the transistors were not saturated. And backing your mic gain off on SSB is the same as backing your power level off. So I know now with all the changes I made in this amp is doing every damn thing it can possibly do, and there's nothing in the world that's going to make it do any more. And that's a good thing. Well, let me rephrase that. Sometimes I stick my foot in my mouth. There's nothing in the world that's going to make this amp do a damn thing more, with the exception of one thing. And I'll show you what that is. No science, real simple. Everybody knows this. Battery's charging at 10 amps right now. Battery voltage is now up at 14.3. A little bit less flattening up there. We're not quite running into the block wall quite as bad. The amplitude has came up. It's not going to be super noticeable to you. But if you looked at top to bottom height on the scope right now compared to what it was, it's going to be just a little bit higher. Put it back in analog mode. You can see it's not clamped up on the top like it was before. Still is a tiny bit, but not nearly as bad. So if we could hold that voltage at 14.4 volts, it would actually get even better than what it is just looking at it there last on the scope. More of it would go away. And the reason that's happening is simply because we've raised the voltage to it. It increased the headroom of the amp. And I think using the terms headroom is a pretty fair scenario. You would definitely call it headroom in an audio amp, and an amp is an amp. So if it applies to audio, it applies to RF too. We've increased the headroom by increasing the voltage supply to it. Hello. We're still hitting block wall there, but we got more coming out of the amp. Our battery voltage is now setting 14.5 here. Hello. So we're pinning 200. This meter's a real piece of junk if you want to have any kind of accuracy above 200 watts on it. Definitely want to buy a Bird for that. If I can keep my battery voltage from falling off, I'll get 275 out of this amp. Just at the point where those transistors are just saturated, which is a far cry from 110 watts. It'll probably take 3.5 months for me to edit this video, and you know, I know that nobody will make it past 4.5 minutes, but you know, if I got one person watching, I'm not a teacher, but you know, if one person learned something, call me odd, but you know, it was kind of worth it to me. Don't know what's going to happen to this amp. You know, I'm not trying to sell it by any means. That's sure as hell not the purpose of my videos. Pretty sure it's going to go somewhere. So I appreciate you watching very much today. Thank you. Have a good day.